Hey Philippe, Shaunak, Ognian, this is me. Um, I have two routines. One is a variation of the routines you guys have failing. Um, it's the latest version. I try to filter out bad lines and bad windows, but it doesn't make too much difference. And I also, if you look at my list of routines, I have another one, blue veiling, which is I took this veiling, which now is running automatic, and I take the part of it that was being done manually, and I set that for the blue, just to manually click on lines that I'm pretty sure, I mean, they are absorption line or have some suspicion is absorption lines, and then set the continue level um, as being um, done by clicking the shoulders of the profile, and then do a chi-square on on the template and t-tor to determine which veiling is the one that's gonna minimize the differences. So I have these two routines, and what I'm showing here is in green is the one done automatically that goes up to here, and is saving all the data. The chi-square is minimized or less than 0.0, less than 5%. Now all these spikes here, and I think I show Phillips in Evergreen, they come from bad lines, either windows that have emission lines or telluric lines like water lines. And so water lines are not stellar, right? They are lines from our atmosphere, and therefore they cannot be used to determine veiling. So I would imagine we could, if we want to do presentation, those points could be taken out. We could do a filter on those. Um, so in red is the result of determining veiling at lower wavelength manually for the record number 42. So I'm going to take any record now just to see how these work. Um, let's take a veiling, I don't know, 13, because Friday the 13th. And then it's going to run automatically, right? Let's take some time. If I put the filter to eliminate, like I have here, if I put this filter to eliminate certain bad windows, um, this is not going to appear. This is not going to show up. But yeah, I didn't do because it didn't make a lot of difference, and I think the program is working fine. Okay, so this was the record 13. So record 13 is right here. 13. So plot okay, that's the veiling that comes out of it for the record 13. Then we have some raising going on here, right, with some scattering. Now these lines are 4,200, 100, 200, 300, 4,400. Okay, let's do manually. Let's do manually with the one with the blue, right? So I'm going to compile this. Blue veiling, blue veiling. There you go. So the record is 13, and I'm going to go from 3,800, right? Way before that. In fact, I could do 3,000. Let's see. This is 4,000. Let me try to get 3,900 because I know 3,800. The template is horrible. So then what it does, it plots the T-Tori 13 and the sun, just to make sure we are talking the same language. And now, so the green is template, right? And the white is T-Tori. So now is the problem of, okay, where can I see a line? So for instance, it's hard to tell. I don't see any obvious absorption lines that are matching. So then I skip this window. And the same, see, it's not working fine. No matching at all. Now, you could claim there is a match here. See that? So I'm going to mark a continuum to take this line, and this line here all together. Okay? So I'm going to set the continuum for the T-Tori in white. 1, 1. And now for the template in green. So let's say the continuum goes in here and there. There you go. And then it calculates the veiling 2.35 and go to another line. So this is the region we just got it. But I don't see any other that I could probably make a claim. Maybe here? What do you think? Maybe here? So I would take the T-Tori like this, and the template like this and that. See, it's a bad match, but it's gonna go to the result anyways. Now move the window. What do you think? Maybe here? Maybe here? For the T-Tori and for the template. Then, hard to tell, maybe here, maybe there, all the way there. And then take the template. Or maybe here, how about that, right? And then the template. It's kind of a tilted. That was not a good one, but I can see the veiling is so high. So that was not a good one. So let's go to another window. I don't know. This is weird. There's a mismatch here. Maybe here. Maybe here. So I would say this is... Now the template has a shoulder here. So let's take the T-Tori first and the template. What do you think? Got a 1.25. Let's go to another window and T-Tori, template in green. And this, I don't know how to tell. Let's say T-Tori, template is basically the same. There's no veiling here basically, but this line is masqueraded, so it's hard to tell. It's going to be a big scattering. But this is funny. See, this is bad reduction in the blue. So where is the continue for the template? I don't know. So I'm get out of here and get out of here. So this line is a chromospheric line. See, it's a central emission here. What was in absorption becomes in emission. So this is not good. But maybe here is a good one. There you go. Go to another one. Oh, it's right here. Look at this. This is good too. Maybe from here to there, from here to there. About here. Tutorial and template. So basically, what the software does, those points that I click, it does a linear interpolation between those 2 points and find a continuum, just a straight line, and divide both template and spectra of tutorial by that line. Now we are in 4,600. It's hard to tell. I could probably get here and there. Excuse me. It's another chromospheric emission here. How about another chromospheric emission here? This is a good one here. Look at that. I'll take that, and continue there. Maybe here. Both for template and tutorial. So basically what we are doing, we are saying, okay, in the blue, up to 4,100 toward short wavelength, I can't trust what the software does automatically. So I'm doing manually. So that's basically what we are doing. And well, that's gonna be a huge, huge one. Oh no, that's not bad. And I'm just put a straight line there. There you go. See that? It looks nice. It looks real nice. Is this the same? No, I'm lost. I think it's the same. Click on a continue left or line. If no line undone, I click on left side of the window. Now I can do here one line. Look at this, from here to there, from the green to the green. There you go. And then calculate the veiling. And from here, maybe to here, and from there to there. There. That's enough. And then we are in 4,200, right? A little bit more about here. There. That would be more quadratic than linear. There you go. And how about from here, there, here, there. Okay. So let's say we are done, right? If you want to stop, click right of the window. So I'm click here, and then it's saved. Okay. So as we saw before, this is done automatically, right? Now, what I'm going to do now is to bring the spectra number 13 in the blue, which came here. See, TWB veiling, blue veiling 13. So if I click on this, I have the WB and veil. So if I do that and we'll plot WB veil PS for symbol is equal 5, and color is equal 140 maybe. See what we got. Make another color. So as you can see, it doesn't add much. It put a lot of scattering. So what we can say, the veiling has a tendency of growing. So we can use that as an argument to give an error bar in the blue that can be somewhere in there. What's the source of errors? Because, well, the lines, first of all, the reduction, the automatic reduction package might not be that efficient in the blue. Okay. Now, here is what we are standing for now. Do we want to calculate for 92 files these data in the blue with very good precision? I would say maybe not. I mean, unless we want to model that region. But what I'm trying to say is, for now, I think we are. I think I'm happy with the outcome of this routine, and I would say we have. Let's say we have H alpha that is 6,600 somewhere here, right? So we want to correct that H alpha emission for veiling processes. So how do we do? Well, we take the average of these points, or a median somewhere here. So that would be a veiling of 0.4 or 0.5 or so. And then we apply that correction on the line. And then we can get a better constraint in the flex variation. Okay. So that's what I'm leaning forward now. So basically what I will do, I will run this routine in all the files, all the records I have, and then when it calculates, I will, when everything is calculated, I will make it available. So we can do that. How we can go like this. For any variant of the 1, 92 to begin, and then do veiling, and right, because if it's gonna get record 1, smooth in 10 pixel, rotate 4.4, do it automatic, and go in jumps of 10 windows each, and 4. That's it. So then it's going to be calculating that automatically. So when it's done, then I'll say, and then I think the next step for us would be to really start calculating emission and go to the lines and be happy with it. Unless Philip or Shaunike want to try some different approach for veiling. That would be cool too, as far as to get a training in the calculation, but I would think for now wouldn't be that much necessary. I think we can start getting some excitement in following real variations of the stars. Okay, all right, so that's it. Let me know.